In the machine learning community, we usually think of logistic regression as a classifier, a black box that takes features as inputs and produces a belief distribution for some target. However, in the statistics community and other scientific disciplines, regression is typically used to determine the relationships between the features and the target. For example, we could try to model the relationship between various health characteristics and the risk of having type 2 diabetes. When logistic regression is used in this context, there is a lot of emphasis on the statistical significance of the analysis. From the machine learning point of view, large confidence intervals correspond to overfitting. To reduce the size of these confidence intervals, we need to introduce more information into the modeling procedure. One way of doing this is to take a Bayesian approach. In the Bayesian setting, before looking at the data, we construct a prior distribution over the model parameters that encodes our knowledge about what the underlying relationships could be. This prior is then combined with the data to provide a posterior, where we may end up having a more precise estimate of the model parameters. The process of constructing a prior in collaboration with a domain expert is known as prior elicitation. The usual Bayesian approach combines the prior and the likelihood associated with the data. We take the intra-Bayesian view that knowledge obtained from the domain expert is just another form of data and should be treated as such. This results in an inference rule with two likelihood terms, one for the training data and one for the prior knowledge. Our goal is to automate the prior elicitation process. We do this by instructing the LLM to be a domain expert, describe the features in our dataset, and tell it what the target is. The knowledge that we elicit from the LLM is in the form of synthetic training data. However, we elicit a label distribution from the LLM instead of a one-hot label, as previous work on prior elicitation has shown this is crucial. Our experimental results show that using this new inference rule with synthetic data from an LLM can sometimes substantially improve the sample efficiency of Bayesian logistic regression. Please see our paper for more details. If you would like to keep up to date with this work as we further develop it, please follow the GitHub project.